Hello everyone, I would welcome you all to Startup Academy, India's exclusive coaching for ISS examination, which is exclusively for ISS only. And before starting today's concept, I will like you to enlighten upon you on the Lakshya 2027 batch. We have two batches. One is fulfilled, one is full. The second batch is almost full, and there are very limited amount of seats that are left. So those who are interested can enroll now. The classes will be beginning from 15th of July 2026 onwards, and there is no time, so we have very little time to take you in. In the middle, we won't take any student. Anyhow, you can appeal to us. We won't be taking it. From the very beginning till the very end, we keep our students the same. We don't take anyone in between the lectures or in between the year. And we'll be your guiding light from the starting of your journey. That's our aim. So that is our strategy for doing the ISS 2027, cracking it up and making you an officer of Indian Statistical Service. Okay, that's it for today. Now let us begin with today's lecture. Today, we will be considering again the last 10 questions of Statistics Paper 2 of Series A. I'm again and again telling you that if you have papers of Series B, C, or D, you can see the question number can differ, but the questions will remain same. You can see that. And the last topic that we will be covering will be linear models. Today's lecture will include question number 51 to 60. Rest all we have completed. Okay. So this is our first question, which is question number 51 of today's lecture. Let us see what they have given. They have given A is a matrix having 6 columns with rank 3, and y be a non-null vector. The number of linearly independent solution of a consistent equation Ax is equals to y is. First of all, for a matrix, suppose we are taking a matrix A of m cross n. Okay, this is the matrix having m cross n order. So it will be having the formula. The formula for this matrix is rank of this matrix plus nullity of this matrix should be equal to the column, which is n here, the number of columns. This is the formula that we have many a times done in our courses, and we have given the notes in which it is very much included. So this is those who have done the course with us, this was nothing but just the revision of those things, so it was an easy one. So from here we can see rank has been given as 3, nullity we don't know, so I am putting it as nullity of A, and the column is given to us as the order of the column is 6. So from here we can say that the nullity of A is equals to 3. 6 minus 3 will be 3. Now they have given y is a non-null vector and the number of linear independent solution of Ax is equals to y. So the number of linearly independent solutions of Ax is equals to y when y is non-null is given to us by the formula as nullity of A plus 1, which is equals to 3 plus 1, 4, and hence our option number B is the correct option. So this is the theorem behind it. We are not discussing the theorem in detail because I have already told you that we are just putting the values in the theorem and finding the answer. Okay. Now moving towards another question, which is an equation based question. Question number 52. There are two equations that has been given to us. Let us see what are they. So first of all, they have given us a linear model y is equals to x beta plus epsilon, and g is the generalized inverse of x dash x. G is equals to x dash x inverse. Okay, this has been given to us. Now the first equation has provided us that x g x dash is invariant, means is unaffected to g. Yes, this is true. Whatever value we take of g, this is a theorem that we have discussed in very detail. Whatever the value states that xg1 dash x, xg2 dash x is equals to same. G3, G4, or whatever value you take of g's will give the same answer. So we can say that xg x dash is invariant of g. So this statement is correct. Now moving towards our second statement, which states that this is symmetric only when g is symmetric. So they have given us SGX dash is symmetric only when G is symmetric. This is not wrong, right? Because whatever way G is, either it is symmetric or it is asymmetric. Then only either it is symmetric or it is asymmetric, this can be symmetric. That is also one of the theorems, so this statement is wrong, and hence our option number A is the correct option for this question. That means only one equation follows. Okay. Now this is our question number 3, another question including statements. So the first statement states that rank of the generalized inverse of a matrix A does necessarily have same rank as A. So if we say that rank of A inverse is greater than equal to rank of A. So it can be equal to or it is greater than. It does not necessarily have same rank as that of A. It does not have. So this is wrong. This statement is wrong. Now moving towards another statement, which is rank of generalized inverse of a matrix A is same that rank of A if and only if it is reflexive inverse. Now what is reflexive inverse? Reflexive inverse is a theorem that if a matrix follow these two theorems, which is that A is equals to A, A inverse A, and A inverse is equals to A inverse A, A inverse. If these two conditions are followed, then our matrix is a reflexive inverse, and hence rank of generalized inverse of a matrix A is same that the rank of the matrix, and hence this is the correct statement. From here we can say that option number B is the correct statement for this question. Okay. Now moving forward with another question, which is question number 54. Here they have given us uncorrelated observation with unknown variance, some uncorrelated observation y1, 2, 3 and 4, and they also have given us expectation of y1, 2, 3 and 4, and they have defined two variables e1 and e2. Then they have asked us the unbiased estimator of sigma square. So first of all, let us consider expectation of y1. Expectation of y1 is equals to expectation of beta 1 plus expectation of beta 2 plus expectation of beta 3, right? but they have given us beta 1, beta 2 and beta 3 are unknown parameters. So we cannot say anything about that. So first of all, let us consider E1. If we consider E1, then let us take variance of E1. If we take variance of E1, it will be variance of 1 by root 2 y1 minus 1 by root 2 y2. Okay, we are taking this. So variance will be 1 by 2 variance of y1. If we take variance of y1, it will be, because they have unknown variance y1, y2, y3 and y4. So it will be sigma square plus 1 by 2 sigma square, which will give us sigma square. And similarly, variance of E2 is also equals to sigma square. Okay, let us keep this. Now we find the expected value of E1. Expected value of E1 is 1 by root 2 expected value of y1 minus expected value of y2. Now expected value of y1 and expected value of y1 both y2 both are same. If we subtract them, we will be getting value answer as 0. And similarly, we will be getting expected value of E2 is equals to 0. From these two equations, variance and expected values, we can get expected value of E1 square is equals to sigma square, because variance of x is equals to expected value of x square minus expected value of x whole square, and expected value of E2 square is also equals to sigma square. So we have calculated this. Now we have to calculate the unbiased estimator of sigma square. How do we calculate this? If we take expected value of, let us consider equation number A. If we take half expected value of E1 square minus expected value of E2 square. Now from here, E1 square and E2 square has the same formula, so this will subtract and will give us 0. But we have to find that expected value should be equal to sigma square to be an unbiased estimator of sigma square. So let us take another formula which has positive sign. So expected value of E1 square is sigma square. Expected value of E2 square is sigma square upon 2 from the outside. It will be 2 sigma square upon 2, which will give us sigma square. And hence we can say this option B is the correct option, which is half E1 square plus E2 square is the unbiased estimator of sigma square, because the answer is coming, expected value of this is coming as sigma square. Okay, this was as easy as this. Now moving forward to our question number 55. Question number 55 is again your PYQ and has been repeated n number of times in the revision series as well, in your course as well. So it was easier. So Gauss-Markov linear model has been given. Y1, Y2 and Y3, three variables have been given. And beta 1 and beta 2 are the blues of this and are uncorrelated. So the formula here that follows is covariance matrix is uncorrelated, which means that the covariance matrix is equals to 0. We will take beta 1 and beta 2 is equals to 0. Let us consider this. Beta 1, we have to consider the numerical part, the coefficient of beta 1 and beta 2. For y1, it is 1 and 1. For y2, it is 1 and minus alpha, and for y3, it is 2 and minus 1. So how do we consider covariance matrix? We will be multiplying the coefficients of these. 1 into 1 plus 1 into minus alpha plus 2 into minus 1 should be equal to 0. So this will be 1 minus alpha minus 2 is equals to 0. Alpha will go on right hand side and it will be 1 minus 2, which is minus 1. So the final value of alpha is minus 1, which is our option number B. This is how we construct the matrix and solve it. Okay. Now moving towards another question. This has been repeated n number of times in your examination, and this is very much important for your examination point of view. So question number 56. They have given us three uncorrelated variables y1, y2, y3 and common variance and expectations they have given us. So, and we have to find the blue best linear unbiased estimator of beta 1 plus beta 2. So, first of all, let us consider L. Let us suppose that L is a linear combination of y1, y2, y3. So, let us say it is c1 y1 plus c2 y2 plus c3 y3. Okay. So, let us consider expectation of L. Expectation of L will give us C1 expectation of Y1 plus C2 expectation of Y2 plus C3 expectation of Y3. Okay. So it will be expectation of Y1 has been given to us as beta 1. Expectation of Y2 has been given to us as beta 2. Plus expectation of Y3 has been given to us as beta 1 plus beta 2. And on the left hand side, the expected value of this should be beta 1 plus beta 2. Right? Now comparing both the sides, we will be getting C1 plus C3 is equals to, okay, I am writing it one more line, beta 1 plus beta 2. Now we take similar coefficients together. So C1 plus C3 into beta 1 plus C2 plus C3 into beta 2, right? So comparing the coefficients, C1 plus C3 is equals to 1, C2 plus C3 is equals to 1. From both these equations, we can say that C1 is equals to C2 is equals to 1 minus C3. Okay, we have got this. Now we will be talking about the variance of L. Variance of L will be equal to C1 square plus C2 square plus C3 square. Since they are uncorrelated, so covariance terms will vanish. And the variance, common variance have, let us say they have common variance sigma square. Okay. Now variance of all these are this. Now we can keep the values of C1, C2 and C3. It is 1 minus C3. Okay, so in place of C1 and C2, we will keep 1 minus C3. So it will be 1 minus C3 whole square plus 1 minus C3 whole square, I am writing 2 outside, plus C3 whole square is equals into sigma square. So it will give us 3C3 whole square minus 4C3 plus 2 into sigma square. This will be given to us. Now we will be differentiating this variance of L with respect to C3, and then we can get the value of this. So it will be 6C3 minus 4 is equals to 0. So putting the values here, we will be getting C3 is equals to 2 by 3. And when we get C3 is equals to 2 by 3, C1 is equals to C2 is equals to 1 by 3, because it is 1 minus C3. So we have got this. Okay. Now we will be putting the values of C1, C2, C3 in L. L is equals to C1 y1, which is 1 by 3 y1 plus C2 y2 1 by 3 y2 plus C3 y2 2 by 3 y3. So it will be y1 plus y2 plus 2y3 upon 3, which is the best linear unbiased estimator of our given equation, our given beta 1 plus beta 2. And hence our option number C is the correct option for this question. I hope you got the answer. How to calculate it, we have discussed it in very detail. Okay. Now let us consider this question. Question number 57. So question number 57 has given us two models. Model 1, y is equals to beta naught plus beta 1x, and model 2, y is equals to beta naught plus beta 1x plus beta 2x square. And they have given us P, which is the residual sum of square of model 1, and Q, which is the residual sum of square of model 2. And they have given us two statements, P is greater than equal to Q. So the first, excuse me. So the first statement, which is given that P is greater than equal to Q, is correct because there is one extra term in this model 2. You all know that. So the more number of parameters in any model, the lesser is its residual sum of square. So Q represents model 2. So its residual sum of Q represents the residual sum of square of model 2. So the maximum number of parameters 1, 2 and 3 are here. So Q will be having less residual sum of square as compared to P, which only have two parameters. So the statement 1 is correct. Now talking about statement 2, which is it can happen that Q is equals to 0 but P is always greater than 1. If we consider this is A plus Bx, and if we consider this is A plus Bx plus Cx square, right? So this can be termed as a straight line and this can be termed as a quadratic polynomial or quadratic equation, right? Now if we take 3 points, suppose we are taking point 0, 0, point 2, 0, 1, point 3, minus 1, minus 1. So if we put these 3 points, all 3 points will be satisfied by the quadratic equation if we plot them. But if we put these 3 points in a straight line, they won't be satisfied by the straight line. 2 points will be satisfied by it, but the third point won't be satisfied by it. So P always has to be greater than 0. It can't be equal to 0. But in quadratic equation, it can happen that the residual sum of square is equal to 0. So because it can take as many points as it can and it can plot it. Okay, that is the reason behind this. So statement 2 is also correct, and hence our option number C is the correct option for this question, which is both 1 and 2 are correct statements. Now moving towards question number 58. What does question number 58 states? That there are two students, student 1 and student 2, those who have fitted the model. So student 1 have fitted the model yi alpha naught plus alpha 1 cap xi, that is y on x. So if we talk about Pearson correlation coefficient, so it has the formula, it is represented by R. So if we talk about R here, R is equals, R has been given to us as, or instead, alpha is given to us as R. They have taken y over x, so sy over sx, right? This is the formula that we usually use for Pearson correlation coefficient. And for student 2 has used x on y. So for it will be beta R Sx Sy. Now if we multiply these, alpha into beta, so it will be equal to r square. If we see xy and x will cut down from numerator and denominator, and r square always lies between 0 and 1. So we have these two statements. One statement is this and one statement is this. Now considering these statements, we have been given values of alpha and beta. First of all, they must lie between 0 and 1. Multiplication of both of them should lie between 0 and 1. And one more thing is there, that both the signs of alpha and beta should be same. Sign should be there. Okay. So we will cut down equation option number A and option number C, because they are having different signs. One is having minus and the other is having positive. So option A and C cuts from here. Now we are left with B and D. So let us consider option number B and D. If we see B, then our alpha is minus 0.7 and beta is 3.5. So let us multiply them. 0.7 into 3.5, which will be equal to 2.45. But now this is greater than 1. So this cannot be our option because it should lie between 0 and 1. So we are only left with D. Let us check it for that as well. So it is minus 1.5 into minus 0.3. Minus minus will get plus, and 1.5 into 0.3 will be 0.45. This lies between 0 and 1. This is lying between 0 and 1. And this also have same sign. So all the conditions are satisfied. Hence our option number D is the correct option for this question. Okay. Now moving towards question number 59. 59th has given us the estimable lambda dash b is an estimable function of beta, and y is equals to x beta plus epsilon, expected value of this that, and they have given us to consider the following statement. So they have basically given us the model and details about the model. So first of all, let us consider that they have given us the value of x dash x beta is equals to x dash y. From here we can say that beta cap is nothing but x dash x inverse x dash y. Multiplying by x dash x inverse on both sides, we will be getting this. Now first statement states that lambda beta cap is equals to r dash x dash y. So the next statement that has given to us is x dash x r is equals to lambda. They have given us lambda dash beta. So first of all, we will be taking the transpose on both sides. So it will become lambda dash, and then we will be multiplying by beta cap. So taking transpose, it will be x dash x transpose r transpose. R is a scalar, so it comes outside, and multiplying by beta cap on both sides, lambda dash beta cap. What is the value of beta cap that we have found out? It is x dash x inverse x dash y, which is lambda dash beta cap. Now if we see this clearly, even if it is transpose, the inverse of a transpose is the inverse of a square matrix. That inverse of a transpose of a square matrix is equals to the transpose of that matrix only. So this, all of this get cancelled. This is if we write it transpose or not, it doesn't matter. It will get cancelled, and we are left with r dash x dash y, which is lambda dash beta cap. So the first statement says that lambda dash beta cap is equals to r dash x dash y, which is correct for any beta cap or r, and hence equation 1 is correct. Equation 1 is Correct. Now talking about equation 2. They are saying lambda dash beta cap and r dash x dash y are invariant to the choice of beta. Yes, in the first statement they have given for any beta cap or r. So the second statement also satisfies that, and hence our second statement is also correct. So our option number C is the correct option, which states that both the equations are correct equations for this question. Now moving towards the last part of our last question of the day, which has been given to us as Gauss-Markov linear model, and they have given us to find the value of L, which belongs to a real number of dimension n, where expected value of L dash y is equals to 0. Okay. Now from here they have given us expected value of L dash y is equals to 0. Now y can be written as x beta cap, so we can take it as expected value of L dash, in place of y it is x beta plus epsilon. Now we all know that expected value of epsilon has been given to us 0, so we are left with L dash x beta cap. Expected value of beta is beta cap is equals to 0. From this equation we can confer this. Now from here we can say that L dash x is equals to 0 because beta cap cannot be equal to 0, so this must be equal to 0. And from here we can say that L must be orthogonal for x. L should have been orthogonal for x, that is why this is equals to 0. The multiplication of two matrices is only is equal to 0. Suppose we are taking two matrices A and B. The multiplication of both of them is only equal to 0 when they both are orthogonal to each other. Okay. So here we are considering L dash is orthogonal to this. Now x has the space equals to r, the x has dimension equals to r, which is given. So the dimension of L dash must be, what will be the value of dimension of L dash? It will be the total dimension minus the dimension of R. So this should be the dimension of the subspace. Okay, of the this should be the subspace of R, real numbers of dimension n whose dimension is n minus r. So this is the final answer, and this is our option number D, which is the correct option for this. A subspace of Rn with dimension n minus r. Okay. First, once again I'm telling you this because this is a difficult question. They have given us that expectation of L dash y is equals to 0. In place of y, we have written the value of y, x beta plus epsilon. When we take expectation inside, we take it expectation of beta cap, beta will become beta cap, and expectation of epsilon they have already given to us as 0. So we are not writing that. So here L dash x must be equal to 0 because beta cap cannot be equal to 0. Either one of them can be equal to 0, should be equal to 0 to give the answer as 0. Okay, so we have removed beta cap and we have taken the actual information that we got from here, that L dash x is equals to 0. If L dash x is equals to 0, then the both of them are orthogonal to each other. So we are saying that L must be orthogonal to the space of x. Now two matrices to be when they are orthogonal, when multiplied gives the answer 0. That is why we are considering this. Okay. Now from here we know that x has a dimension of r. The dimension of x is r. Okay. Now, and the total dimension that has given to us is n. So the dimension that will be left for L dash will be total minus the expected dimension of R, which is n minus R. And hence our final answer will be L belongs to R is a subspace of Rn, which is real number n with dimension n minus R. And hence our option number D is the correct option. Okay, I hope I was able to make you understand this one. So this is it for statistics paper 2 of 2026. We have done whole of the series. If you haven't watched the all the other videos, you can watch it right now. It is available on our channel. And if you are seeking further help in coaching, then we have launched our batch very priorly to the even prior to the examination of 2026, and it is for 2027. Our batch is known as Lakshya 2027. Very limited amount of seats are left, and on 15th of July we will be starting the course, one full year course full of mock test courses, uh, the live classes, the doubt classes, as well as the recorded lectures. Everything will be provided to you, and in very detail, we will be discussing every topic. Those who have just begun their journey, I would recommend them to join the coaching as soon as possible, because after that, we won't be taking any student in between of the classes. So that's it for today's lecture. I hope that you understood. All the best. Thank you.